Here are some numerical problems related to the motion in a straight line. First question is, in 1 second, a particle goes from the point A to point B moving in a semicircle in the figure. The magnitude of the average velocity is. We know that formula for average velocity is net displacement by total time taken. In the figure, net displacement is the direct distance between A and B, which is equal to the diameter of the circle. So it is the diameter and time taken is say t. Diameter is double of the radius by time, and radius is given 1 meter and time is also given 1 second. Therefore, average velocity will be 2 meter per second. Hence option B is the correct option. Second question is, a particle moves in a circle of radius r. In half the period of revolution, its displacement is and distance covered is. If a particle revolves on a circle, then from point A, if it starts after the half of period of revolution, it will reach at a point B, which will be diametrically opposite. So displacement is the direct distance between A and B. It will be the diameter and it will be the twice of the radius. So displacement will be 2r, and distance will be the length of the path traversed by the body, and this will be the half circle, that means half circumference, and total circumference is 2 pi r if radius is r, hence distance will be pi r. So distance covered will be pi r. This is the answer. Third question is, a particle is moving eastwards with velocity 5 meter per second. In 10 seconds, the velocity changes to 5 meter per second northwards. The average acceleration in this time is. We know that acceleration is a vector quantity and average acceleration is given by rate of change in velocity. And change in velocity is the final velocity minus initial velocity by the time taken. If we draw the velocities as per the reference direction, this is east, west, north, south. Then as per question, initially velocity v1 is equal to 5 meter per second in eastward direction, and in 10 seconds this velocity changes with magnitude 5 meter per second. This is v2 in northward direction. So change in velocity will be the vector from v1 to v2. This is the change in velocity, and this change in velocity has the magnitude 5 root 2, and direction will be, from figure we can see, this is north, this is east, west, and direction of delta v is in the northward direction. Therefore, the velocity delta v has direction in the northwest with magnitude 5 root 2. So average acceleration will be equal to 5 root 2 divided by time taken 10. So it will be equal to 5 get cancelled, it is 2, and root 2 by 2, this will be equal to 1 by root 2, and direction is northwest direction. Hence option C is the correct option. Fourth question is, in three-dimensional system, the position coordinates of a particle in motion are given by x equal to a cos omega t, y equal to a sin omega t, and z equal to a omega t. The velocity of the particle is. We are given x, y, and z coordinates, so we can write the position vector of the particle as xi. I is the unit vector along x-axis plus jy and kz. I, j, k are unit vectors along x, y, and z axis respectively. So we can write r is equal to x is a cos omega t I plus y is a sin omega t j plus and z is a omega t k. So velocity is rate of change of position vector. So it will be differential of a cos omega t I plus a sin omega t j plus a omega t k. Differential of sum is sum of differential, so we can write it as differential of a cos omega t I plus differential of a sin omega t j plus a differential of a omega t k. This will be equal to constant terms will be taken out and we will differentiate the variable term. So A is constant, I is also constant, so it is AI, and differential of cos omega t will be minus omega sine omega t, plus similarly A and J are constant and differential of sine omega t will be cos omega t into omega, plus A, omega and k are constant and differential of time with respect to time will be 1. Hence we have I into minus A omega sine omega t plus A omega cos omega t j plus A omega k. Now we have to find the magnitude of the velocity. So magnitude of the velocity will be equal to the square root of the components of velocity square, that is Vx square plus Vy square plus Vz square. Here this term is Vx, this term is Vy, and A omega is Vz. So we will have it is equal to square root of Vx square is A square omega square sine square omega t, Vy square is A square omega square cos square omega t, and Vz square is A square omega square. If we take the common A square omega square from these two terms, it will be A square omega square. Remaining is sine square omega t plus cos square omega t, and remaining is A square omega square. This sine square omega t and cos square omega t is 1. This is the trigonometrical identity. So we will have finally square root of A square omega square plus A square omega square, which can be written as A omega root 2. Hence, option A is the correct option. Fifth question is, there are one or more correct options. The position vector R of a particle of mass m is given by the following equations. RT equal to alpha t cube I plus beta t square j, where alpha is 10 by 3, beta is 5, m is 0.1. At t equal to 1 second, which of the following statement are true about the particles? For t equal to 1, if we have to calculate position R1, it will be alpha t cube. Alpha is given 10 by 3, t is 1, so it is 1 cube into I, plus beta, which is 5, into t square, it is 1 square into j. So position vector will have the value 10 by 3i plus 5j. This is the equation number 1. Then we have to find the velocity. Velocity at time t will be the differential of position vector. It will be equal to differential of position vector is alpha t cube I plus beta t square j. Constant terms are taken out, so alpha I and differential of t cube will be 3t square plus beta into j, and differential of t square is 2t. Now velocity at time 1 second will be equal to, substituting the value of t square and t equal to 1, we will have alpha is 10 by 3 into then I into 3 into 1 square plus beta is 5 j into 2 into 1. Therefore, it will have the value, this 3 and 3 get cancelled. So remaining is 10i plus 10j. So as per the question, part A shows that velocity A is given by v equal to 10i plus 10j meter per second. So option A is the correct option. In part B, angular momentum. Angular momentum L is given by r cross p. It can be written as r cross mv. This is the linear momentum. So we can write this is m into r cross v. M is given 0.1 kilogram and position vector r is given at time 1 second. It is 10 by 3i plus 5j. Cross multiply with velocity at time t equal to 1 second. It is 10i plus 10j. In cross product, we know that I cross I equal to j cross j. equal to k cross k are 0 because angle between them is 0 degree. And also I cross j is k and j cross I is minus k. So using this, we will have 0.1 into, on cross multiply this I and I, it is 0, then 10 by 3 into 10, then I cross j, plus this j cross I, that is 5j cross 10i, and other term is j cross j, that will be 0. So it will be multiplying 0.1 with the quantities inside the bracket, we will have, it is 10 by 3, I cross j is k, plus 5, and j cross I, ki is minus k. Therefore, it will be equal to 10 by 3 minus 5 of k, or it is minus 5 by 3 k. So option B is the incorrect option because momentum is here given positive while actually it is negative. In part C, the force F is given by, we have to calculate the force. Force is defined as the m into a, mass into acceleration. So mass is 0.1 and acceleration is rate of change of velocity. First we have to differentiate the velocity with time, and velocity we have find that it is, here it is alpha I into 3t square plus beta j into 2t, and if we substitute the value of alpha and beta, it will be equal to 10 by 3 into I into t square into 3 plus 5 into j into 2t. This 3 and 3 get cancelled, so it will be simply I into 10t square plus j into 10t. And now we replace this v here, it is I into 10t square plus j into 10t. So it will be equal to 0.1 into, differentiating, I and 10 are constant and differential of t square is 2t, plus j into 10 is constant and differential of time t is 1. And substituting the value of time equal to 1 second, we will have force at 1 second will be equal to 0.1 into I into 10 into 2 into 1 plus j into 10. So it will be equal to, multiplying 0.1 inside the terms within the bracket, it will be I into 2 into, and this is plus j. So it will be equal to, this is 1. So it is 2i plus j. Hence option C is also incorrect. Part D is, we have to find the torque at time 1 second, and it will be equal to the cross product of the position vector and the force. At time t equal to 1 second, the position vector is given by 10 by 3i plus 5j, and cross with the force at t equal to 1 second, that is 2i plus j. On taking the cross product, this I cross I will be 0, so remaining is 10 by 3 into I cross j, plus then j cross I, it is 10 into j cross I, and j cross j will be 0. I cross j is k and j cross I is minus k. So this will be equal to 10 by 3 into unit vector k minus 10 into unit vector k. So it will be 10 by 3 minus 10 with unit vector k, or it is equal to minus 20 by 3 unit vector k. Hence option D is the correct option. Sixth question is, a particle is moving with velocity v equal to b root x along positive x-axis. This is the one-dimensional motion. Calculate the speed of the particle at time t equal to tau. Assume that particle is at origin, that means position is x equal to 0 at time t equal to 0. Velocity is given b root x. So in one-dimensional motion, we can write dx by dt equal to b root x, or dx by root x is equal to b dt. Integrating, we will have dx by root x equal to integral b dt plus a constant of integration, which will be calculated using the given conditions. On integrating a root x, we will have root x by 1 by 2, that will be equal to bt plus c, or 2 root x will be equal to bt plus c. This is equation number 1. It is given that at time t equal to 0, x equal to 0. So on substituting in equation 1, we will have constant of integration is 0. Therefore, our equation is 2 root x is equal to bt, or we can write root x equal to bt by 2, and on squaring we will have x equal to b square t square by 4. Now we differentiate x with respect to time. Differentiating with respect to time, we will have dx by dt, which is the velocity or speed here in one dimension, and it will be equal to differential of b square t square by 4. B square by 4 is constant, so we have to differentiate t square with respect to time, and which is 2t. These two get cancelled, so remaining is b square t by 2. So velocity is at time t equal to tau equal to b square tau by 2. Hence option B is the correct option. Seventh question is, a particle moves from a point 2i plus 4j meter at t equal to 0 with initial velocity 5i plus 4j meter per second. It is acted upon by a constant force which produces a constant acceleration 4i plus 4j meter per second square. What is the distance of the particle from the origin at time 2 seconds? As per question, it is given that initial position r0 is 2i plus 4j meter at time t equal to 0, and initial velocity is u, which is given by 5i plus 4j meter per second, and constant acceleration is 4i plus 4j meter per second square. So we can use equation of motion because acceleration is constant, and equation of motion says that position vector at time t is equal to initial position plus ut plus half a t square. We have to find the position at time t equal to 2 seconds. So it will be equal to, substituting the value, it is 2i plus 4j plus u, initial velocity is given 5i plus 4j into 2 plus half into acceleration is given 4i plus 4j, and time is 2 square. So it will be equal to 2i plus 4j plus 10i plus 8j plus, here this 2 get cancelled and remaining is 8i plus 8j. Now we will add the similar term with similar terms, like the terms which have the unit vectors I will be added. So this is 2i plus 10i, it is 12i, and then 8i, it is 20i. And terms which contains the unit vector j are 4 and 8 12 and 8 20. So this is the position vector of the particle at time t equal to 2 seconds. So distance of the particle from the origin will be the magnitude of the radius vector, and it will be square root of x square plus y square, and x component is 20, so it is 20 square, plus y component is also 20, 20 square, so it will give 20 root 2 meter. Hence option B is the correct option. Eighth question is, a particle of mass 10 raised to power minus 2 kilogram is moving along the positive x-axis under the influence of a force Fx equal to minus k by 2x square, where k equal to 10 power minus 2 Newton per meter square. At time t equal to 0, it is at x equal to 1.0 meter, and its velocity is v equal to 0. Find the velocity when it reaches x equal to 0.5 meter. Here force is minus k by 2x square, and this force is mass into acceleration, which is a function of x, is equal to minus k by 2x square. Therefore we can write that acceleration is minus k by m into 1 by 2x square. It is given that mass is 10 raised to power minus 2 kilogram and k is 10 raised to power minus 2 Newton meter square. So substituting these values, we will have minus 10 to the power minus 2 by 10 raised to the power minus 2 into 1 by 2x square. These two terms cancelled. So acceleration ax is equal to minus 1 by 2x square. Now this acceleration can be written in terms of the position as this is v into dv by dx. It will be equal to minus 1 by 2x square. So we can write it as v dv equal to minus 1 by 2x square into dx. Integrating, we will have integral v dv equal to minus of integral 1 by 2x square dx plus constant of integration. This c we have to calculate it with given conditions. This will be equal to integral of v will be v square by 2. It will be equal to minus 2 is constant taken out, and integral of x square will be minus 1 by x plus c. So this can be written as v square by 2 is equal to 1 by 2x plus c. Initial condition is given that at time t equal to 0, object is at x equal to 1.0 meter and velocity is 0. So we have to use this condition. We have velocity is 0 equal to 1 by 2 into x is 1 meter plus c. This implies that c will be equal to minus 1 by 2. So we substitute this value of c. We will have v square by 2 is equal to 1 by 2x minus 1 by 2, or v square is equal to 1 by x minus 1. As per question, we have to find the velocity when the object is at position x equal to 0.5 meter from the origin. So we have to replace this x equal to 0.5. We will have v square is equal to 1 by 0.5 minus 1, that is equal to 2 minus 1, and it is equal to 1. So this implies that velocity may be plus 1 or minus 1 meter per second. That means it may be moving along the positive x direction or negative x direction, which we have to check. As per question, it is given that the object with respect to origin is at a distance of 1 meter at time t equal to 0, and a force is acting on it, which is given by F equal to minus k by 2x square. This force is negative, that means directed towards the origin. So because of this force, the object will move towards the origin, so velocity will be negative. Therefore, we will discard the positive value and velocity will be minus 1 meter per second. Hence, the correct answer is 1 meter per second with minus sign, showing the body is moving towards the origin in the negative x direction.